So welcome students. So today we will start interfacing to external memory. So far you have seen that in the last few video lectures we were mostly discussing about how to interface different external devices with your 8051 microcontroller. So we have studied how to interface with analog to digital converters, how to interface with motors, etc. So today we will see how to interface with external memories. So many times before you have seen that we discussed about several instructions like move X, etc., or move C. So this X stands for external. So this instruction is mostly to fetch data from an external memory or to send data to an external memory. Then move C is associated with sending and bringing data from external code memory, etc. So in this lecture you would be able to appreciate more of these things. Okay, so what exactly is meant by external memory and how they are important in the context of storing data and code, and then trying to implement larger memory space for your 8051 microcontroller to operate. Okay, so let's move on. So let's first look into different types of memory that you can have, and the first one is the semiconductor memory. Okay, so here the number of bits that semiconductor memory chip can store is called its capacity. Okay, so it can be in units of kilobits or megabits or sometimes gigabits also, depending on how large is the memory. And this must be distinguished from the storage capacity of computer systems. Okay, so while the memory capacity of a memory chip is always given in bits, okay, the memory capacity of a computer system is given in bytes. Okay, so when you say 16M memory chip, you actually refer to 16 megabits of memory. So bits is the thing that you are referring to. In case of a computer, when it comes with let's say 16M memory, then you are actually talking about 16 megabytes. Okay, so this distinction has to be kept in mind. So the semiconductor memory chips are organized into a number of locations within the IC. Okay, so each location can hold either a single bit or 4 bits or 8 bits or 16 bits, depending on how the memory is designed internally. Okay, and the number of locations within a memory chip depends on the address pins. So again, these things uh, you have come across previously. So the number of bits that each location can hold is always equal to the number of data pins. So we discussed about address bus before, so and also about the data bus. So if we have like 8 data pins or 8 lines in your data bus, then you can have the data ranging from 0 to 2 to the power 8. And in case of your address bus, usually this is a 16 bit address or 16 address pins, so you can have total addressable space between 0 to 2 to the power 16, right? So same concept we are revisiting here. So therefore, to summarize, a memory chip contains 2 to the power x location, where x is the number of address pins. Okay, and each location contains y bits, where y is the number of data pins on the chip. Okay, so the entire chip, the capacity will be 2 to the power x times y. So these many bits that will be contained in the entire chip. So one of the most important characteristics of a memory chip is the speed at which its data can be addressed. So to access the data, first the address is presented to the address pins, then the read pin is activated. So there will be a read pin in most memory chips, and after a certain amount of time the data shows up at the data pins. Okay, so the shorter this time, the better is the performance, so the better is the chip, and therefore the more expensive will be the chip. Okay, so the faster it is, the more expensive it is. So let's say a Pentium chip is more expensive than your usual 8051, and that's because a Pentium has a faster processing power. Okay, so that's what is meant by what you are seeing in this slide. So the speed of the memory chip is commonly referred to as access time. Okay, so let's look into some examples. So let's say a given memory chip has 12 address pins and 4 data pins. So find the organization and the capacity. So the organization means like how this memory chip is organized into different slots. Okay, and what are the width of those slots. Okay, so this memory chip that we are talking about has 4096 locations. So 2 to the power 12 gives you 4096, and each location can hold 4 bits of data. So this gives an organization of 4k times 4, often represented as this. Okay, and the capacity is equal to 16k. So as simple as that, 4k times 4 is 16k bits. Okay, kilobits. This is important since there is a total 4k locations and each location can hold 4 bits of data. Now let's look into another example. So a 512k memory chip excuse me, has 8 pins for data. So find the organization and the number of address pins for this memory chip. So 512k, this is the total capacity, okay, which is given. Okay, so it has 8 data pins, which means that each location within the chip can hold 8 bits of data. That part is fine, but to find the number of locations within this memory chip, you have to divide the capacity by the number of data pins. So this is the capacity of the memory chip, which is 64k. Because in the previous example you see that this times 4, or 4k times 4 gives you the capacity as 16k. So where 4 was the number of data bits, here the number of data bits is 8 and the capacity is 512k. So basically this is a 64k times 8 chip. So that's the organization, and 64k means you have 16 address lines for this particular chip. Okay, as simple as that. So now let's look into the different types of memory again. So the first is the ROM, or read-only memory. So this is a type of memory that does not lose its content when the power is turned off. Okay, so that's why sometimes it's also called non-volatile memory. Okay, there are different types of read-only memory. Okay, depending on whether they are programmable and erasable, etc. So these are the different types: PROM, EPROM, EEPROM, flash EPROM, and mask ROM. So let's go through these one by one. Okay, so in case of your programmable ROM or PROM, you have a programmability associated with it. So in case of your PROM, a user can burn information into it. Okay, so PROM is user programmable, and for every bit of the PROM there exists a fuse. Okay, so you are basically burning that fuse to write information in that ROM. Okay, so when you have a fuse, let's say that is a 1, and when you burn the fuse, that is 0. Okay, so in that way you can store binary information in the ROM. If the information burned into PROM is wrong, then that PROM must be discarded. You cannot do anything, because once these internal fuses are burnt, that's a permanent change. Okay, so they are blown permanently. So if you have mistakenly burnt a fuse, then you have to discard it and you have to do it again. So that's why PROMs are also referred to as OTP, or one-time programmable. Okay, so programming the ROM, which is also called burning the ROM, requires some special equipment. Okay, so called ROM burner or ROM programmer. Okay, so that's the PROM for you. Next comes the erasable programmable ROM, or EPROM. So in this case, what happens is that you can erase whatever you have burnt. Okay, so in the previous case of PROM, as you saw, that if there is something wrong in the programming process, then you have to discard it. In this case, in EPROM, you can erase the contents. Okay, so basically you can change. Okay, so EPROM was invented to allow making changes in the contents of PROM after it is burned. Okay, so this is important here. So in EPROM, one can program the memory chip and erase it thousands of times. Okay, and how is that done, that erasing part? So a widely used EPROM is called EEPROM, where you can use ultraviolet light, okay, to erase the contents of the PROM. So the only problem here is that your EEPROM is that it takes up to 20 minutes. So this is a long time actually to erase its contents. Okay, so the basic concept is that if you expose to UV light, then the contents will be erased, but then it takes a lot of time to actually erase the contents. So all EEPROM chips, they have a window that is used to shine ultraviolet radiation to erase its contents. Okay, so that is erasable programmable ROM, or EPROM. To program a EEPROM chip, the following steps must be taken. So first, its contents must be erased. So first it has to be cleared. Okay, so this is equivalent to clearing if it has any previously written contents. So it is removed, to erase a chip, it is removed from its socket on the system board and placed in this EPROM eraser equipment. Okay, so this is nothing but something to expose it to UV radiation for 15 to 20 minutes. Okay, so in that way the contents gets erased. Now that it is erased, so you can program it fresh. So to program the chip, you place it in the ROM burner. To burn code or data into EPROM, the ROM burner would use this 12.5 volts voltage VPP in the EEPROM datasheet or higher, depending on the EPROM type. Okay, and then you place the chip back into its system board. So there are 3 steps. First, the ROM is taken from the system board and placed into the eraser equipment. Then it is brought back to the burner, and then once the programming or the burning is done, it's placed back into the system board socket. Okay, so there is a separate programmer and a separate EPROM eraser equipment, and that's the major disadvantage actually of EEPROM, that it cannot be programmed while in the system board. So it has to be moved back and forth from the system board to the eraser equipment, and then back to the burner, and then to the system board. Okay, so this is one disadvantage of EEPROM. Notice that the pattern of the IC numbers, okay, so for example 27128-25 refers to an EEPROM that has a capacity of 128 kilobits. So this 128 stands for the capacity, and the access time is 250 nanoseconds. Okay, so this 25 refers to 250 nanoseconds of access time, and 27, the 27 at the beginning always refers to some EEPROM chips. Okay, so let's see an example. So for the ROM chip 27128, find the number of data and address pins. So this 128 refers to a capacity of 128 kilobits, so therefore it has 16k times 8 organization, because all ROMs have 8 data pins. So therefore it indicates that there are 8 pins for data and 14 pins for address. So 2 to the power 14 gives you 16k. Alright, so let's move on. Next type of ROM is electricity erasable PROMs, or EEPROM. So this has several advantages over the regular EPROM, and basically that is to do with the eraser procedure. So the method of erasure in case of your EEPROM is electrical and therefore instant, okay, as opposed to this 20-minute eraser time that you had for EEPROMs. So one can select which byte to be erased in contrast to EEPROM. So this is another advantage, okay. So in case of your EEPROM, the entire contents of the ROM are erased when you expose it to UV light. But in case of this EEPROM, you know, you can choose which byte to be erased, and one can program and erase its contents while it is still on the system board. So this is also very important, okay. You don't have to move the ROM here and there. So EEPROM does not require an external eraser and programming device. So the designer incorporate into the system board the circuitry to program the EPROM. So this is again a big advantage as opposed to the EEPROM, okay. Next comes the flash memory EPROM. So flash EPROMs has become popular since the early 1990s, okay. So the process of erasure in case of this flash EPROM is very fast, okay. So the erasure takes place in less than a second. So in other words, you can erase the entire contents of this EPROM in a flash, okay. So like within a fraction of a second. So that's why the name flash memory comes. And of course the erasure method is electrical and it is commonly called flash memory, okay. The major difference between the regular EEPROM and the flash memory is that the flash memory's contents are erased, then the entire device is erased, okay. There are some flash memories which are recently made so that the erasure can be done block by block, but generally speaking the entire contents is erased. So one can erase a desired section or byte on an EEPROM for some so one can erase a desired section or byte on a EEPROM, but flash memory, apart from few exceptions recently, the entire contents are erased, okay. So so it is believed that the flash memory will replace part of the hard disk as a mass storage medium. Actually this is the case already, okay. So the flash memory can be programmed while it's in its socket on the system board, and it is widely used as a way to upgrade the PC BIOS ROM, okay. So I don't know whether any of you are familiar with this, but the early PCs, um, I mean, not very early, at the start of this millennium also, um, like you could do this PC BIOS ROM upgrade, and there will be a blue screen appearing, and and they were actually using this flash memory EPROMs. So you can program the flash memory while it's still on the system board, on the computer motherboards. Okay, the flash memory is a semiconductor memory with access time in the range of 100 nanoseconds. So focus on this term nanoseconds. So it's very less. Okay, so the access time is very less, so therefore it's very fast compared with the disk access time in the range of tens of milliseconds. Okay, so this is also good. Okay, you need a faster RAM, sorry, a faster ROM, and the flash memory actually, conforms to that. Flash memory's program erase cycles must become infinite like hard disks. Okay, so you can program and erase these flash memories infinite number of times. Okay, so the erase cycle or program cycle refers to the number of times that a chip can be erased and programmed before it becomes unusable. So in case of your flash memory, like you can have 100,000 for flash, but EPROM, sorry, you can have 100,000 for flash and double EPROMs, but for UV EPROMs this is only 1,000. Okay, so you can actually program and erase your flash memories like 100,000s of times. The next memory is called mask ROM. So this refers to a kind of ROM in which the contents are programmed by the IC manufacturer. Okay, and it's not user programmable. So the terminology mask is used in IC fabrication. So from there this term comes. So since the process is very costly, this mask ROM is used when the needed volume is high and it is absolutely certain that the contents will not change. Okay, so the main advantage of this mask ROM is that is that its cost. Okay, so you might get confused here. The process is costly for sure, but then this mask ROM is used when the needed volume is high. Okay, so when you are producing this costly item for a large volume, okay, then the cost per item actually gets reduced. So this is basically following a concept in economics called economy of scale. Okay, so that's why mask ROM is significantly cheaper than other kinds of ROM. But then if an error in the data or code is found, then the entire batch must be thrown away, and this is something which you don't want. Okay, so you can see there is a good and a bad, there are pros and cons. Okay, for mask ROMs. So next we will move into random access memory. So far we were talking about ROMs, which were non-volatile in nature. Basically, if you write something or if you program a ROM, then it stays there. Okay, but RAMs are volatile in nature. Okay, so the RAM memory is called volatile because after this power is cut off to the IC, so okay, of 45 is the supply voltage. If that is switched off, then it will result in the loss of data. So whatever is the content of the RAM, that will be erased automatically with cutting off the power. So sometimes this RAM is also referred to as RAM, read and write memory, in contrast to ROM, which cannot be written to. So ROM stands for read only memory. RAM can be read and written to. So there are three types of RAM again: static RAM, non-volatile RAM, and dynamic RAM. Okay. So let's look into those one by one. So in case of a static ROM, the storage cells, okay, are made of flip-flops, okay, and therefore do not require refreshing in order to keep their data. Okay, so a flip-flop, as you know from your digital logic modules, okay, digital electronics modules, so it can store 1 bit of data. Okay, so if you store uh, data in this flip-flop, so the RAM is made of several flip-flops, and if you have if you are storing 1 or 0 in those individual flip-flops, that will stay unless the power is switched off. Okay, but you will see that in some type of RAMs you use capacitors, okay, instead of flip-flops. In those cases you have to refresh them in order to keep the data. Okay, so you have to refresh the charge of those capacitors. So static RAMs, you actually use storage flip-flops. However, when you use flip-flops for storage cells, each cell require at least 6 transistors to build. Okay, so for holding 1 bit of data, you are using 6 transistors. So this is not very feasible. Okay, I mean, in recent years the cells have been made of 4 transistors, which still is too many. Okay, the use of 4 transistor cells plus the use of CMOS technology has given birth to a high capacity static RAM, but then its capacity is far below the dynamic RAMs. Okay, so that's the disadvantage actually of static RAMs. Next comes the non-volatile RAM. So non-volatile RAM combines the best of RAM and ROM actually. So the read and write ability of RAM plus the non-volatility of the ROMs. Okay. So NVRAM chip internally is made of the following components. So it uses extremely power efficient SRAM cells built out of CMOS. Okay. And then this is interesting. It uses an internal lithium battery as a backup energy source. Okay, so this is interesting, and this actually provides the non-volatility. Okay, so when your supply voltage is switched off, okay, then this internal lithium ion battery will keep charging or providing, providing energy to this SRAM cells so that they can hold the data. Okay, so it uses an intelligent control circuitry. So the main job of this control circuitry is to monitor the VCC pin constantly to detect loss of external power supply, and whenever the external power supply is lost, the control circuitry will switch on these lithium batteries to support this RAM cells, and in that way they can keep the data and become non-volatile in nature. Okay. Next comes the dynamic RAMs. So the dynamic RAM uses a capacitor to store each bit. Okay, and therefore it cuts down the number of transistors drastically that are needed to build the cell. However, it requires constant refreshing due to the leakage, because if it is a capacitor, as you know, the capacitor charge falls down like this, it decays exponentially with time. Okay, so therefore you need to constantly refresh these DRAMs. Okay, so the major advantage are high density because you have less number of transistors, cheaper cost per bit. Okay, which is very obvious because you are using a capacitor to store a bit instead of, let's say, 4 to 6 transistors, so the cost is cut down, and lower power consumption per bit as well. Again, this is obvious because you are using less number of transistors. In fact, you are using a capacitor. However, the disadvantage is that it must be periodically refreshed, and then while it is refreshed, the data cannot be accessed. Okay, so these are the disadvantages of the DRAMs. So the next concept, after that we have talked about this RAMs and ROMs, the next concept that we are going to discuss is the memory address decoding. Okay, so the CPU provides the address of the data desired, but it is the job of the decoding circuitry to locate the selected memory block. Okay, so we are talking about interfacing your microcontroller, right, with external ROMs or RAMs. Okay, ROM/RAM, let's say. So in between these interfacing, there has to be some decoding circuitry. Okay, and the purpose of this decoding circuitry is to locate the selected memory blocks. So there will be multiple blocks inside this ROM or RAM, depending on how this decoding circuitry. So this is basically, this decoding circuitry is a combinational logic circuitry. Okay, or sometimes it's a separate standalone chip, and its main purpose is to provide a logic that would select a certain portion of the memory locations inside this RAM or ROM. So memory chips have one or more pins called the chip select, which must be activated for the memory's contents to be accessed. Okay, sometimes the chip select is also referred to as chip enable. Okay, so which output of this decoding circuitry will go to the chip select, which output will go to which pin of this RAM and ROM, external RAM and ROM, and then from the microcontroller side also, which of the ports will be connected to this decoding circuitry. So these details are important to have a proper interfacing of an external memory. Okay, and we are going to learn that in the remainder of this lecture. Okay, so let's talk more about memory address decoding. So in connecting a memory chip to the CPU, so the data bus of the CPU is connected directly to the data pins of the memory chip. Okay, and the control signals that we have, so read and write from the CPU, are connected to the output enable and the write enable pins of the memory chip. Okay, and in the case of the address buses, while the lower bits of the address from the CPU go directly to the memory chip address pins, or the upper ones are used to activate the CS pin of the memory chip. Okay, so this is what is the high level arrangement. Okay, and normally the memories are divided into blocks, and the output of the decoder selects a given memory block. Okay, so while you are talking about interfacing your microcontroller with an external memory, then these are the different arrangements. Okay, so the data bus goes to the data pins of the memory. The control signal read and write from the CPU are connected to the output enable and the write enable. In case of the address buses, the lower bits of the addresses from the CPU go directly to the memory chip. The upper ones are used to activate the CS pin of the memory chip. Okay, and then the address pins. Okay, they are used to activate the several blocks of the memory, and those address pins, they go through a intermediate decoding circuitry. Okay, which can be implemented using simple logic gates, or it can be used it can be implemented using ICs like the 74LS138 or using programmable logics. Okay, so here is a simple example of memory address decoding. So it's a simple logic gate arrangement. The simplest way of decoding circuitry is the use of these NAND gates, okay, or other gates also. So in fact, that the output of the NAND gate is active low, and that the CS pin is also active low. This makes a perfect match. Okay, so you can see how these interfacings are done. So let's say this is your external memory. Okay, so this is a 4K times 8 memory. The organization of the memory is this, and let's say the data output of the microcontroller D0 to D7, okay, they go directly to the D7 to D0 of the memory chip. A0 to A11, these lower bytes of the address bus, they go directly to the A0 to A11 pins of the memory chip, okay, and that is fine because this is actually 12. So they have 12 bits of address here, okay, and 12 address pins. So since it's a 4K memory, so 2 to the power 12 is 4096, which is 4K. So you have 12 address pins, and A0 to A11 of the address bus of the microcontroller goes directly to A0 to A11, okay. And now what will be happening with A12 to A15? Okay, so these 4 address lines of the microcontroller actually goes through this decoding circuitry, okay, which is implemented using this NAND logic circuit, okay, and the output goes to the chip select, okay, and then the read and write is connected to the memory read and memory write signals, okay. So let's focus on this logic circuit, okay. So A15 to A12 must be 0011 in order to select the chip, okay. So the output of the NAND gate, okay, has to be active low, okay. So if your A15 to A12 is 0011, okay, in that case only, okay, let's say if this is 0 and this is 0, so here it will be 1, here it will be 1, 1 and 1, okay. So all of them combined will be 1, and then the output will be 0, okay. And this chip select is a active low, so when there is a 0 in the input, this memory will be activated, okay. So what does that mean in principle? Okay, so if you write down A15, A14, A13, A12, okay, and then A11 to A0, let's say, okay. So this is fixed. This has to be 0011 because your decoding circuitry is such that to activate this memory chip, you have to have 0011 in A12 to A15. And if I write it in that way, 0011, and then A11 to A12, which goes directly to the address pins of this memory chip, this could range between all zeros to the case of all ones, okay. So therefore it means that the range of addresses, okay, that this interfacing circuitry can, you know, can access is between 3000 hex to 3FFFF hex. So if you write this 0011, okay, so 0011, and then let's say all zeros, etc. So this is actually, this part is 3, and then the remainder is also like 0000, okay. So if you write, if you arrange 4 bits at a time, I don't have space here, and then you can see that in hex this is 3000 hex. Okay, and the all one case for A11 to A0 will give you 3FFF. So the range of addresses that you can access is 3000 to 3FFF, and you can see how this decoding circuitry actually affects this range. Okay, so the memory address decoding that we are studying is very important. It's the way your microcontroller is interfaced with an external memory through a decoding circuitry. That is important because that gives you the range of addresses that you can access within this memory block. Let's say this is a 4K times 8. Okay, but you can only access a certain portion of this memory, which is defined by 3000 hex to 3FFF hex. Okay, so I'll stop here actually, and I will continue the rest of the discussion in the next video lecture. Okay, so I'll stop here for today. Thank you.